A novel ensemble deep learning model for stock prediction based on stock prices and news. Abstract. In recent years, machine learning and deep learning methods have gained popularity in the field of financial data analysis. However, reliable prediction is made difficult by the influencing factors. This paper explores a blending ensemble learning model to be used in such cases. Through experiments, it was seen that the blending ensemble learning model that was built was able to predict stock prices with much greater accuracy than its traditional counterparts. Introduction. The stock price changes react to supply and demand. The primary factors that affect the stock supply and demand are company news, company performance, industry performance, investor sentiments, economic factors. Stock price prediction is a series of continuous predictions of the stock prices while keeping the above factors in consideration. Traditional models use either textual data like news, tweets, or numerical data like stock prices information instead of using both textual and statistical information. And this is one of the inconsistencies in the traditional models. The other inconsistencies in the traditional model are previously used models consider only one or two factors, which is not enough to forecast the stock price trend. Previous works or only use the target company's information on the training model without considering that the target company's competitors. Previous works use textual information but do not often consider time series. However, the timeline is considered as a significant factor for stock price prediction. It is also a challenge for computer scientists to use AI to predict future stock movements because it is hard for a computer to receive the latest information and respond immediately. Literature review. The stock prediction domain has seen a multitude of predictive models over the years, but there have been 5 approaches in the recent years that fundamentally influence this research. They are as follows. First is basically the use of LSTM networks. So this uses technical analysis indicators with baseline models like SVM, random forest, and MLP. One of the greatest problems in using ML in stock price prediction is the inability to take into account factors such as big events and news. The second is the hybrid attention network. This focuses on efficient learning to reduce noise for low quality data, resulting in better prediction. Next. Third is the more robust LSTM. So differential privacy was used to make the LSTM model mentioned previously more robust. Then we have the deep learning for stock prediction using numerical and textual information. So this research attempted to convert newspaper articles into distributed representations. Finally, we have RNNs with character level language models. Methodology. So data source. The team had collected data from a research paper called as DP-LSTM Differential Privacy Inspired LSTM for stock prediction using financial news. The team has classified data into two categories, news and stock data. The news data was obtained primarily from the following sites, that is CNBC, Reuters, WSJ and Fortune. The stock data was collected from the S&P 500 index. The dates range from December 2017 up to the end of June 2018. This paper uses only adjusted closing stock prices as a target value. The next step of methodology is the data preprocessing step. In this, the news data was preprocessed with Aware Dictionary and Sentiment Reasoner to generate sentiment scores. So VEDA is a lexicon and rule-based model for general sentiment analysis. It gives us how positive or negative the sentiment is by giving us a compound score ranging from -1 to 1. During the preprocessing, all the null data was removed from the dataset. So weekends in the dataset were not included as stock market is only open on weekdays. The data has been split into three parts: training data, validation data, and test data. The training data are those obtained from 12/7/2017 to 4/9/2018. The validation data ranges from 10/4/2018 to 5/4/2018. and the test data ranges from 5/7/2018 to 1/6/2018. So for time series forecasting, a rolling window with fixed size 10 is used to provide different time steps. Since the compound scores are numbers from between -1 to 1, and to avoid overfitting and improve accuracy, values were rescaled between 0 and 1. So this is basically the schematic diagram of the time step window. So as we can see, in total we have 121 trading days, out of which 83 days were dedicated for the training set, 19 days was dedicated for the validation set, and another 19 days was dedicated for the test set.
Model building. After extensive research, it was concluded that combining multiple RNNs provide a more accurate prediction compared to a single LSTM network. The team here deployed a blending ensemble learning model that combines LSTM and GRU. For the LSTM unit, the amount of memory content that is seen is controlled by the output gate. The GRU unit exposes its full content to other units without any control. When LSTM receives new content, it transports it to the forget gate, which decides what information will be thrown away or be kept before the computation process. The GRU utilizes update gate to control the previous unit's information flow when computing the new candidate activation. The LSTM prediction is more close to the actual stock price. GRU outperforms LSTM both in terms of convergence in CPU time, parameter update, as well as generalization. Ensemble learning technique uses both these models to complement each other. The LSTM learning method combines decisions from multiple submodels to a new model and then makes the final output improve the prediction accuracy or the overall performance. The concept of ensemble learning is to use different types of machine learning and deep learning models combined to make predictions or classifications. The chosen parameters here are epoch size, number of neurons, and number of layers. This model contains two layers, level 1 LSTMs and level 2 GRU. Trained level 1 models are used to make predictions on the validation data, that is level 2 models training data. Test data is used for final accuracy and prediction. The activation function used in this case is ReLU. In this experiment, four main evaluation metrics were used. The first is mean square error, MSE. The second is confusion matrix. The third is movement direction accuracy, MDA. And the fourth is mean prediction accuracy, MPA. Precision and recall were used to obtain the F1 score. On this slide here, we can see the confusion matrix for the experiment conducted. On this slide here, we can see a tabular representation of the evaluation results based on the evaluation metrics decided previously for all the different models that were discussed in this paper, along with the blending ensemble model, which shows to have a much higher rate of accuracy than any of the others. This graph here shows a prediction result of the blending ensemble learning model compared with LSTM, DP-LSTM, GRU test model, averaging ensemble, and weighted average ensemble models. Conclusion. This paper proposes a novel deep learning architecture to predict stock prices by combining multiple recurrent neural networks to form a blending ensemble learning model. According to one of the global tech news organizations, such as Nicola News, if a machine learning or deep learning model can reach 60% accuracy on predicting stock movement directions, it can deliver solid returns. This model can reach up to 67% in MDA on the holdout test dataset. This paper points out to six main areas of future research. The first being fine-tuning of hyperparameters. The second being that the results can be further improved using technologies such as cluster SVM and cluster deep learning models. The third is combining more models with the LSTM. The fourth is application of reinforcement learning in this field. Next, it also shows the use of fuzzy logic systems and fuzzy deep learning systems. Dynamic changing of the historical window size based on the type of news can also help improve the accuracy. Here on these slides, we can see the different references that were used in the research of this paper. Thank you.